213 digital logic using hardware descriptive language, and today is October 26, 2024. We are going to talk about sequence detector and sequence generator on the basis of finite state machine, which we have studied earlier, but how to make finite state machine, that we have not studied yet, but we have studied one example on like up and down counter, right. So, in up and down counter, how to make the finite state machine, that we know, and how to derive its circuit, that is also known to us. But there is a next thing, which is sequence detector and sequence generator, for which there are two kind of machines are used, very famous. One is called Milli and one is called Moore. This is not the same Moore. Have you heard about this Moore? Have you heard about Moore? Okay, Moore. There is something called Moore's law. Anyone who knows Moore's law? Anyone? No? So, there is a gentleman called Gordon Moore, who was co-founder of Intel. He passed away last year only. So, he made a law that every year in a given area of the chip, the number of transistors will be doubled. That was his law, and every time the transistor will be shrink by 0.7 times. So, this Moore is different than that Moore. Okay. He has not made that law. So, first Milli came and then Moore came. They have talked about finite state machine. Finite state machine and state variable diagram, both are same thing, right. This is known as a finite state machine. If you look at the diagram, if it is a Milli machine, then the output depends on input as well as the current state, current or present state, whichever you can call it, right. So, if you are asked to design a Milli machine or the circuit using Milli machine, then it is expected that output will be depending on input and present state or current state. But whereas it is a Moore machine, then output is only depending on the present state. There is no role of input, right. That was actually, like, this is summary of what we studied. This is, first one is the Moore machine, where next state is function of present state and input. This is also true in the case of Milli machine. However, in the case of output, Moore machine depends on only present state, whereas Milli machine's output depends on both the things, present state as well as input. So, this is the definition wise. Many places, many competitive exam, they are asking this, right. If you want to remember, you can remember it, right. So, how to design a sequence detector? So, these are the steps which I have written. First of all, first thing is you have to draw an FSM. So, finite state machine you need to draw. Then you need to count the number of states. Depending on the counting the number of states, you need to find out how many number of flip flops will be required or how many bits are required for a given state. By knowing that, you can assign the codes to the representative states, and here I have not written, but in case if some of the states are remaining, let us say in your finite state machine 5 states are available, let us say A, B, C, D in E. If you are assigning here 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1 and 1, 0, 0, then the remaining states also require to find out that where it will go in FSM. If you do not do that, then it will create lots of problem. In reality, when you will have the circuit, that circuit will not function as we want, because these remaining states will also be present over there. And once it is done, you know how to write down the state table using the excitation table. for the required flip flop, for keeping the things easier for us, because we have practiced enough on JK flip flop, RS flip flop. So I'll take only D flip flop, which is the easier one, so that I can solve it as quick as possible and I can spend time on the first three, which is more important here. And from that you can find out the logic diagram. So let's start with the first thing, which is you have to detect a sequence, right? This is, which is 1101. This is what I need to do. 1101, this has to be detected. It is coming from somewhere. Let's say, okay, I have not explained, but generally there might be somewhere a transmitter and receiver. So transmitter and receiver might have some generation of code. So I generate a code, I send it to somewhere, and then through satellite it come back, and in receiving end I am detecting whether it's the same code or not. So both transmitter and receiver maybe are in, let's say, in different cities, and I am sitting it at receiving end, and if code was sent was 1011, if it is damaged, it might become 0100, then I should not detect it, right? I should detect only 1011 in this case. So this is the application majorly for detecting a sequence. It is coming serially. By the way, this is a serial code, right? It's not a parallel code, it's coming serially. So it has to be detected at the receiving end. So this is detector, and other side there is also generator is also available, where you are going to generate the code. So both the things we need to learn. So first of all, detecting where the input is coming from somewhere. If you remember, the X input we used to call an output as Y, and between the states, if you remember, if I am writing like this, then X equal to 0, Y equal to 0, it's traveling from A to B, right, when input is 0. So we have to look at the input which is coming from somewhere, and that input we need to find out as 11001 in whole sequence. And once this is done, then my output should become 1. So this is coming serially, and output is giving 1 at the end of the complete sequence, 1101 only. So how to do that? Let's start with one example. So 1101 I want to detect, and I am looking at, let's assume that there is one state called A. If input is coming 0, input is equal to 0, then it is not part of this sequence, right? I need to detect the first thing as 1, but it's coming 0, so it's wrong. So I am keeping it here itself, and 0 and 0. So whatever state it was, A, 0 is going to be like not going to start with the sequence, so it's staying there. But in case if there is an input 1, but I have detected only 1, right, not completed the whole sequence, so I should write down 1/0. So when 1 is coming, then it will go to the next state. Now if 0 is coming, let's say after 1, 0 has received, then this whole thing is gone, right? We wanted to receive 1101, but it's coming 10, so it's a wrong code. So it will start from beginning only. So what I will do, if the code is 0 with the output of 0, it will go back at the beginning from where we have started. Again it will start looking for 1. So 1 is received, so it will go to B. But again if it is 0, no, this is wrong, so it will again stop. I am looking for 1 after 1. So if right after the detection of first code 1, if next one is coming 1, it should go to the next level where it's detecting 1 1. So if you are at C, 1 1 is already detected. That's the meaning of that. Now in case if I am detecting 0, then it's a Good news, I need to go to the next state because it's completion of 110, right. But in case instead of that, if I am receiving 11, right. So, this is at this point, if I am receiving 1, then what should we do? Should we go back to 0, or if it is YA, you look at this, right. Still I can use that, it's overlap. So, no need to go to A, I can go to B, right. Still the declaration is 0 as Y output, right. Now, at D, when I have received 110 is received, if you are at D, 110 is received already, right. Now, I need to receive 1. If I am receiving 1, then it's good, it's a good news. It will go to the next one, and at that time I am going to call declaring 1, right, because output has been detected. But what if this is 0? If it is 0, should I go to A? When this is E, there are 2 more possibilities are there. If it is 0, then also it stays here, and if it is 1, then also stays here, right. So, it's up to you people. Some people might want to go this way also, like it's up to designer, you might want to go this way, 0 also here and maybe 1 also here. This is also one possibility, that once detected I am looking for next 1101, right. If you want that, then go with this one. If you do not want that, and once it is declared you want to close it forever, I am not taking any more input, then just stop it here. So, it is depending on the designer. If you are doing this one, then it is done, it is detecting 1101 only once, and then no more inputs are being taken. Yeah, I made it. Okay, this is similar to that. The only thing is, here I am assigning A as 111, B as 110, C as 101, D as 100, and this one as 011. So, I assigned these red colored codes to the respective states, right. Still there are 3 states are left, which are 000, 001 and 010. If they are there, then what is going to happen? So, in the case of 00, I will start with here only if the input is 0. But in this case, if 1 is there, then I can go to B, because 1 is already there, right, it is generated, 1 already generated. From here 1 is already generated. So, I am looking for the next one. Why should I go here? If I go to A, then also it will give the answer. The only thing is computation time will be higher. It will involve 1 extra state, but that is also the correct answer. You can do with that, there is no problem, right. When A equal to D is going to E. So, that is 1101, and thereafter I am closing this. It is only detecting 1101 only once, thereafter there is no detection. I am closing it. Thereafter whatever input is coming, it remains at E. So, if you are assuming A equal to some value, let us say 111, 101, whichever, 001, 000, any other preference? 110. So, remaining bits are there. So, what will happen? If I am at remaining state and if 0 will come, then I will start from here, right. No, when I am starting and I am landing up at remaining state. This is possible, right? When I start the power, then some unwanted state is coming which is not listed here under A, B, C, D, E, right? So this is one thing. We have to think about when it's becoming 1, then what to do. If it is 1, then I can take it here to B, so that the one string has started already. So 1, 1, 0, 1, and the rest of the things will be as it is. Keeping it using the excitation table and all, you can write down this D1, D2, D0 and all, and you can draw the the K map. You can find out different values of things and you can draw the circuit. Anyway, so now the next one, before going to, so I am going to give you one FSM for solve to for the detector. So you spend time. I'll also come to your desk, and if any problem is there, I'll try to help you out. Okay. So next one is generating. So how to generate? So the simple thing is, this is quite easier than what we did it for the case of sequence detector. 1 means generate and 0 means pause. If it is pause, means you have to be at the same state. Let's say something like this, right? So 1 means you have to go to the next state. Let's say A to B. It's going with the next state with 1 input. If it is 0, it will stay there, and it will have the same state which was previously. Here previous state you need to write down. For this one, the expected state needs to be written. Let's see how to do that. So what is sequence I give? 1 1 1 0 1 1. Okay. Sorry, 1 1 0 1. That's this 1 1 0 1. If I want to generate, how to generate it? So if there is a first state A, if I have 0, then I'll stay where I was. I am not keeping this value right now because I do not know the previous state. If I know that, let's say if the whole circuit was resetted, then keep it 1. If it is if it is resetted, keep it 0. If it is preset, keep it 1. Okay. If it is 1, then go to the next state. For going to the next state, the input requirement is 1. If x equal to 1, then it will generate. What it will generate? The first thing is 1. So I have to write down 1 over here. I am generating at the output. So now I am generating output string, not taking the input string, right? So here it's 1 1. For 0, it will stay there with the previous state. So previous state was 1. So it will stay here with 1. If I go to the next state, it requires 1 as input, output is again 1, and it will remain at the same place if it is 0. For the case of D, 1 and 0, and then 0 and 1, and thereafter, if I want to close the loop, I can close it with, let's say, 1 1 or maybe 0 1. Any case, if I want to keep it 1, if I am keeping here both 1, then keep it here 1. So it is up to the designer. Again I am saying, if you want to keep it 0, then keep it 0 over here. If it is 0, then it's 0 over here, right? So that question mark will be filled up once it's completed. If you do not want that after generation, if you want to be quiet, then right, 0 0 or maybe 0 1 also, 1 0. You can write down 1 1 also, whichever you like to get the completion. No, there is not required because this is the last one, right? then you have to give some value with the assumption that you are resetting the whole circuit or presetting the whole circuit. This is also, if it is not closed, of course you need to always take care of reset and preset. Generally for any digital circuit, it is recommended that give the reset or preset. Yeah. Which one? Zero. E part. So after E, you already generated 1101. This is generated.